Hello, I'm Arifin Julian, and today we would like to talk about threat. Threat is a special topic because threat are important topic in our operating system. In our lectures, we learn it in the section 9 of the UTS ujian tengah semester. And what is threat? Have you ever heard about it, or are you confused? Because maybe some of us ever heard about it in another lecture, right? Yes, we have threat and threat. What is different between it? Threat is something harmful for our system or device, and we learn it in the cybersecurity lectures. But what is threat? Threat is instruction set that should be executed, or we could say basic unit execution in our CPU. We have two types of thread. First one is thread that only could do a single process at the same time, and also known as a heavyweight process. This is not a very efficient system. The thread also could multiple process at the same time, and the process separate in several CPU for processing, yet known as lightweight process. Threads make the system more efficient. So here let us try to understand the concept of the thread. We are using these two diagrams. So here in the first diagram, it is a single threaded process, which we refer to a traditional or heavyweight process. We are having only a single thread. So this whole block is considered as a process, and this process contains only one thread. And this is the code section, data section, and the data file, the register, and the stack belonging to this process. And also here on the right, this whole block represents a multi-threaded process. So it is a single on the left, single process on the left, and we're having multiple threads on the right. So if you see there are three threads in this process, each of these threads they have their own state and register. So all these three threads they have their own stack and register, and if you see on the top of the code section, the data section and the files belonging to this process are shared by these three threads, and each threads they have their own state and register. So this is a diagram of multi-threaded process. So in this case, this process can perform multiple tasks at a time because each thread will be performing different tasks. Hence, multiple tasks can be performed at a time by a help of this multiple threaded process. So from that it has helped, we must have understood that is much more efficient as compared to the single threaded process, and it will make our computation faster and more efficient. So in the most of our system that we use today, we follow the system of multi-threaded process. It will be good if we can visually how it works in our system in order to understand how the processes are and how the threads are associated with the process. And here we go. Okay, I have small software process thread which help us to see the process and the thread running in our system. So if I click here, I can see the process running in my system. So I have opened the Chromium browser in my system. So here I can see the chrome.x process which are running in my system. So there are quite a few number of chrome.x process running in the system. Now if you can see the thread associated with it, I will click and there are some detail on the thread populated in here. So many of the threads associated with a single chrome.x. All of the thread ID, every thread contain the thread ID, and there's the context switch and the last context switch, and then the status, and also the created time, user time, kernel time, And also we have a stack dash, stack limit, and step size. Is all the content in every thread that process in our system. Okay, it's just a simple explanation from me about the thread, how the thread works from the single thread into the and also the with the multiple thread system, and also show you the process thread view application just to understand the basic knowledge of the thread. And also we have to know that every thread share the same files, share the same data, and also the same program. And but they process the different process, like the sample that I shared. The multiple thread process could process more than three or another that every program needs on it. Okay, thank you for watching. Uh, Bye.